how much energy is required to ionize hydrogen atom if the electron occupies n is equal to 5 orbit? Compare your answer with the ionization enthalpy of hydrogen atom from n is equal to first orbit. We know delta E is equal to E2 minus E1. Delta E is equal to E2 minus E1. The energy in the nth level is given as, according to Bohr's equation, take down, En is given as 21.8 into 10 power minus 19 divided by n squared into z squared joule per atoms. Here n is the principal quantum number. Principal quantum number. Z is the atomic number. Z is the atomic number. So here the n1 is 5 here. So let us consider, now we have to apply the equation here. For example, delta E is equal to E2 is nothing but this n2. So you can put 21.8 into 10 power minus 19 divided by, of course, for hydrogen the atomic number is 1. So you can replace by 1. So 21.8 into 10 power 19, this is n2 squared minus 21.8 into 10 power minus 19 divided by n1 squared, correct? So that is equal to here, and in fact in this case it is given as n is equal to 5, n1 is equal to 5, first energy level. This first energy level 2, and it should escape from the hydrogen, means it should reach infinity. Okay, so n2 should be infinity in this case, because it should be removed from the system, hydrogen itself. For example, let me consider the nucleus of hydrogen here, and this is the n is equal to 1 level, n is equal to 2 level, n is equal to 3 level, n is equal to 4 level. I am taking only semicircles. N is equal to 5 level, n is equal to infinity level. Are you able to follow? This is n is equal to 5. This is n is equal to 1. Now this is the final energy level. Okay, so n2 is infinity here. n1 is, in this case, 5. I am talking about this energy transfer only. The energy required to ionize means how much energy is required here, okay, to remove the electron from n is equal to 5 to n is equal to infinity. Do you understand this point? So we are talking about this energy. This is delta E. So that's what we are calculating, and 21.18 into 10 power minus 19 is constant. We can take outside the bracket. Now this is 1 by n2 squared, correct? Minus 1 by n1 squared. Are you able to follow? So this is delta E. So it means delta E is equal to 21.8 into 10 power minus 19. And N2 is, listen to me carefully, as I already mentioned, this is infinity. So 1 by infinity means 0, is it not? Infinity squared. Infinity itself is 0, 1 by infinity. Minus 1 by n1 squared. So 1 by, what is n1? N1 is 5. N is equal to 5. So 5 squared. That is the principal quantum number. So it means 21.8 into 10 power minus 19. This becomes a 0, is it not? Minus 1 by 25. Am I right? Okay. So the final answer you will get in negative. Minus 21.8 into 10 power minus 19 into 0. I mean minus, that is minus I have brought here, 1 by 25. Am I right? So it means 21.8 divided by 25 is equal to 0.872. So 0.872 into 10 power minus 19. Is it not? 0.872 into minus point. This is minus 87 into 10 power minus 19. This much energy, that is in joule. Okay. So you can call this as, that is 10 power minus 20. Is it not? So 10 power minus 20. I write here. So that is equal to, I'm sorry, this is N1, N2 squared. Actually this should be minus here. N2 squared means N1 squared, and this will give you negative value. So that N2 squared means it should have negative value here. Okay. N2 means negative. And finally this is also negative, negative, negative of negative, positive. Okay. Therefore energy is equal to how much? 8.72 into 10 power, and this is 0.872. 8.72 means 10 power 20 minus 20. So 8.72 into 10 power minus 20, this much amount of joules here. Okay. Now what is asked here? This is the energy from the infinity. Okay. Now for ionization from first orbit, because it is given for the ionization, compare your answer with the ionization energy of hydrogen atom. For hydrogen atom, that should be driven from first orbit, but what we have obtained from fifth orbit. Are you able to understand? So for first orbit, how much will be the energy? So in that case, we had to calculate delta E, take down. So this is from fifth orbit, n is equal to 5 orbit. But we need to calculate energy from first orbit. It means delta E is equal to the same formula, 21.8. Okay, 21.8 into, what is the value? 10 power minus 19. So 10 power minus 19, and this is minus, open the bracket, 1 by n2. 1 by n2 means 1 by infinity. Okay, because n2 is infinity. Minus 1 by 1 square. So minus of minus plus, 1 by infinity is equal to 0. So this is 21.8 into 10 power minus 19. So this is the delta E for from n is equal to 1. So we have to compare these two. This is from Let us compare delta E from n is equal to 5 is equal to 8.72 into 10 power minus 20 joule, whereas from n, and this is nothing but ionization energy. Ionization energy. So this is the way we have to compare. Okay, and here you have to be very careful. This is delta n2 minus n1 means that is with the negative sign here. Okay, remember this, right? So it means now this is the hydrogen nuclei, first energy level, second energy level, third energy level, fourth energy level, fifth energy level, infinity energy level. Are you able to follow? Now what we have found out is this is 1, 2, 3, 4, 5. From 5 to infinity, what is the energy required? Are you able to follow? This is n is equal to 5. This is n is equal to infinity. Got it? And this is compared against this energy. Are you able to follow? From first energy. Definitely it will be what? For example, this is the least amount of energy compared to this. Is it not? More amount of energy is required to kick out from electron from the n is equal to 1, because it is very closer to nucleus, and because of its nuclear binding it will be very difficult to remove easily the electron from n is equal to 1. Whereas when it is in excited state, that is n is equal to 5, effortlessly you can take it, so the energy is less. Is it not? So 8.72 into 10 power minus 20 means that is less than that of the n is equal to 1. Or will we follow this? Right.